Namaste everyone. Let us see the third set of MCQs. Here goes the first question. Minimum amount of charge that can be added or removed from a body is. So if you want to charge a body, either you have to add electrons or remove electrons. That is the only possibility. And electrons are the easiest available that elementary particles. And if you can add, and you know that electrons are quantized, and you can't remove half electron or so. So the minimum charge that you can add or remove from a body is the basic charge of an electron. So it should be the charge of electron, or you can also have an answer like 1.6 into 10 to the power 9 minus 19 coulomb. So it should be A. It's the charge of electron. That is the smallest particle you can add or remove from a body. Okay. Second one, two positive charges are separated by a certain distance and are kept in free space. So they are separated. There should be a potential energy between them. As soon as they are allowed to move freely, so if you allow them to move freely, definitely they will repel and they will move away. So as they start moving away, their kinetic energy starts increasing, and that extra energy, kinetic energy, is obtained by reducing the potential energy. So because distance between them goes on decreasing, so potential energy reduces, but kinetic energy starts increasing. So this is the answer. Both are positive charges, so potential energy between them decreases, kinetic energy increases. Equation which represents equivalent form of Ohm's law mathematically is, equivalent for, see, you know, Ohm's law is V equal to IR. So another equivalent form of Ohm's law is J is equal to sigma E. So if you want to put it in the vector form, sigma is not a vector, electric field is vector, J is current density I by A, sigma is conductivity, and E is electric field. J is equal to sigma E is the equivalent form of Ohm's law. 1 Gauss is equal to 10 to the power minus 4 Tesla. So better you remember all these conversions. So this is the answer. Potential energy of a magnetic dipole with its magnetic moment aligned at an angle theta to the external magnetic field is 0 when, so with respect to the angle theta, when will be the potential energy of a magnetic dipole 0? You know that potential energy of a magnetic dipole is minus mb cos theta. This will be 0 when theta is 90 degree because cos 90 is 0. So theta should be 90 degree. The law which gives the polarity of induced EMF in a circuit due to the rate of change of magnetic flux is, and this is a very common problem in most of the question papers. The polarity of induced EMF is given by Lenz's law, and electromagnetic induction principle is given by Faraday's law. Of course, Gauss law you have in magnetism as well as electric field, electricity, electric charges, and Gauss law gives the strength of the, it gives the total flux through any closed surface. Kirchhoff's law is the law of conservation of energy. Okay, here now the answer is not two answers. Lenz's law, not Faraday's law. SI unit of self-inductance is it is Henry, very simple. So better you know the units of different physical quantities. An alternating voltage V equal to Vm sin omega t is applied across an inductor. Current through the inductor is, you know that current through the inductor is, and it should be lagging behind the voltage by pi by 2. I is equal to Im sin omega t minus pi by 2. It should be lagging behind. I equal to Im sin omega t minus pi by 2. Yes. Okay. Right. Then velocity of light in material medium. You know that velocity of light in a material medium depends on the electrical as well as the magnetic properties of the medium, because velocity is 1 by root of mu epsilon. So it depends on both electrical property, magnetic properties, refractive index of the medium, everything, all the above factors. Because even refractive index n equal to c by v depends on the speed of light. Speed of light depends on the refractive index v equal to c by n. Concave mirror of focal length f in air is immersed in water. Its focal length now is, you know that focal length of a mirror, it is a concave mirror, does not depend on the surrounding medium. If you have a mirror of focal length of f, then parallel rays will meet at f, and the focal length is measured. If you do this experiment in water, you will get the same focal length. The point where they get focused is the same, because f equal to r by 2, you have this formula. It depends on the radius of curvature of the mirror. When the mirror is immersed in water, radius of curvature doesn't change. So focal length remains the same. So answer is F. For a lens, it may change. For a lens, when it is immersed in water, it may change. Two Polaroid sheets are kept one over the other. Light is incident on the first and the second one is turned. So if you have one Polaroid sheet like this, say let us keep another Polaroid sheet like this and make the light to fall from back side and let it come out here. That is the experiment. Light is incident on the first and the second one is turned with the incident light as the axis. So we will rotate this one like this. So we'll rotate it. Now, as it is rotated, intensity of coming light out of the second becomes minimum and maximum twice during one full rotation. Now, the incident light is, what is this they are asking? That should be unpolarized, because when unpolarized light is incident on the first Polaroid, it gets polarized. So vibration, suppose this is the path axis, the vibrations may be like this. And when it passes to the other Polaroid, suppose other Polaroid path axis is like this, they are not allowed to come out. When the path axis is parallel to these vibrations, they are allowed to come out. So this is unpolarized, whereas this is polarized. So it is an unpolarized longitudinal wave or transverse wave. Sorry, not polarized. Unpolarized transverse wave. Because polarization can be shown only for transverse waves. So unpolarized transverse wave. In incident light, the light coming out of the first Polaroid, this one, out of this is polarized transverse. Okay. As velocity of electron increases, de Broglie wavelength of the associated with the electron, and lambda is equal to h by p, h by mv. As v increases, you know that de Broglie wavelength goes on decreasing. A. Rutherford's nuclear atom model failed to explain. So according to Rutherford, electrons can occupy any orbit. So as they lose energy, they go on reducing their orbit. So finally, the radius will shrink and the electron should fall to the nucleus. Stability of the atom is not explained by Rutherford. It was explained by Bohr's model. So Rutherford's nuclear atom model failed to explain the distribution of positive and negative charge, that is successfully explained, size of the nucleus explained, size of the atom. Stability of the atom is not explained by Rutherford's nuclear atom model. Difference between mass number and atomic number of a nucleus gives. That means A minus Z. Atomic number is Z. So that gives a number of neutrons. Number of neutrons. See. Diffusion current is produced by the diffusion of. So you know that in a p-n junction, as soon as p-n junction is formed, one side has plenty of holes, another side has plenty of electrons. This is n-type semiconductor, this is p-type. As soon as the junction is formed and when it is left behind, electrons from here move to this end and they fill the holes. So this gets positively charged, this gets negatively charged. So an electric potential is developed at the junction, that is called barrier potential. So this diffusion of electrons and holes, that is majority carriers. Electrons here, majority carriers move here. Holes here, majority carriers move to this side. So that is the motion of the majority carriers. Diffusion current is because of the majority carrier motion across the junction. Whereas drift current is because of minority. Drift is because of minority. So diffusion is because of majority. Drift current is because of minority. Minority carriers on both the sides. Okay, we will want the fill in the blanks question. According to Ørsted, moving charges or current should produce magnetic field. So any current carrying conductor produces a magnetic field. This one, magnetic field. Moving charges produce magnetic field. Dash lasts only as long as there is change in magnetic flux. That is induced EMF. Faraday's law. Induced EMF lasts only as long as there is a change in the magnetic field. As soon as the magnetic field change stops, if the magnetic field is a constant, no induced current, no induced EMF. Bending of light around the narrow obstacles is called diffraction. A very simple definition. So diffraction is over, induced EMF is over. Beta ray is a stream of electrons coming out of the nucleus, and it is not the electrons which are revolving around the nucleus producing beta ray. They are revolving by themselves. They have nothing to do with the radioactivity. Beta ray is actually the electrons coming out of the nucleus, and it is the conversion of neutron into proton and electron. Proton remains inside, electron comes out. That is called beta ray. So nucleus, yes. Then The last one, dash avoids the migration of majority charge carriers across the junction. Barrier potential, just now we have discussed. Barrier potential avoids the migration of electrons and holes. So we have this one extra. Yes. Thank you for listening to me. Thank you.